One, two, three.
Good.
Okay.
Espera aí, não é? Isso é fixe. Não está ligado ao computador.
Está bem, mas isto é de quem?
Olha, está-me a cumprimentar.
Ah, ok. É do Alex.
Ok. Então temos que
Acredito.
Isso agora tem leque, não?
Era o que eu estava a ver. Estava a meter no primeiro buraco que apanhei.
Mal tem que meter no primeiro buraco que apanha para aí. Mas acaba com a mão ligada.
Hey everyone, welcome to the second day of the third Pycon Portugal. So just to recap for those of you that didn't come yesterday and this is your first day here, if you got any technical issues, you have support on Slack, you have email, you can find us with a purple t-shirt, not this one, but this one, or the green lanyard. So anyone with a green lanyard, just go and ask them for help. Quick reminder that we have a code of conduct in the conference. So it's if you have any issues, you can contact us at conduct@pycon.pt, or and if you want to read the full document, you have it on our website. Again, we have lightning talks today. Hopefully from yesterday, those of you that were here already learned the gist of it. There is a whiteboard outside. You just sign your name, the name of the talk. The time limit is 5 minutes. And it can be for any topic at all. It doesn't need to be Python related. It can be anything. So we were in Porto, the first edition, then in Coimbra, now Braga, and the next year we'll see. Maybe. Actually, the workshop rooms are called Madeira and Azores. And that was funny because we wanted like a neutral name. We didn't want to put like 1 and 2. Because we don't want to have like, oh, this one is more important than the other one. And we had someone asking us, hey, like, I'll be in Braga for the talks. How do I attend the workshops? Like, do I need to fly to the islands? Like, no. It's like just the name. And today we have the party. So you don't need to sign up. It's free for everyone. It will be right outside because we were afraid of the weather. So we chose to do it indoors. We'll have some music, some food, and some drinks. And so this will be after the closing session today. You just need to walk out and have fun. If you still want a t-shirt and you haven't gotten yours, you can still get one from the website, the same place where you buy your ticket. You have the t-shirt there, and you can pick it up there, if according to availability. Finally, you can follow us on social media, on X or Twitter, wherever you want it. You can join our Slack and on LinkedIn as well. A big thanks to our sponsors again, Pydantic, Zencoder, then AeroPython Society, the Python Software Foundation, another edition that was not here, the Django Software Foundation, of course the Municipality of Braga, for providing with this venue, and Evolutio. And yeah, without further ado, I would like to invite to the stage our keynote speaker, Alex.
Okay, hello everyone. My name is Alex. I will be talking today with you today about going beyond Copilot with AI agents. Now, before we dive deeper into AI agent world, let me quickly ask you to get to know better my audience today. Who here uses any coding assistants right now? Can I get a show of hands? Okay, and out of those who use coding assistants, does anybody use anything other than Copilot or ChatGPT? Can I also get a show of hands? Okay, just a few people. All right, okay. Now, the agenda for today is we will talk about, first of all, why we need to go beyond the Copilot, what's not so good about it, also known as past. We will also talk about how we can go beyond Copilot, also known as present. And then we will talk about like what's next for you, as a developer. Will AI take over your job or not? And also known as future. So let's start with why. And to answer the question of why, let's first talk about what code assistants are and what they promise for you to have. So usually code assistants do have a set of features which can fall into one of those 4 categories. First of all, obviously, they provide code generation capabilities, and these can be in different flavors. So it can be something you type as a natural language request, and then you get a code generation. It can also be something like code completion, where you start typing, and then you get an autocomplete suggestion on how this line should end. Regardless of the flavor, the end result is you get a code from scratch from some sort of request from you as a user. Another option is code refactoring, or in general, any code editing options, where you can ask, for example, the tool to optimize your code, to refactor your code, or modify it somehow. Or in some cases, it's just a matter of clicking optimize button, and it does some sort of magic behind the scene, and you can't even specify what you want to optimize. There is also, of course, in some cases, error detection, and in some assistants, it also can proactively help you with those suggestions on how to fix those errors. And in a sense, it kind of overlaps with code refactoring because it also usually requires you editing the code. And last but not least, of course, is docs generation, and it's any features around natural language text generation. So, for example, doc strings, or maybe markdowns, or whatever, like pull request summaries, and so on. Now, all of this sounds pretty nice, and the usual promise of coding assistants is that you will be able to code faster, you will be able to code smarter, and so on. Now, of those who use coding assistant, can you confirm that that's the case? Do you use smarter? Do you go smarter, faster? I can see some no's. Okay. Well, yeah. So usually, if you just tap, for example, for autocomplete, you might get a lot of code. But unfortunately, you still need to debug it. You need to validate that it's actually working. And usually, once you get some code, it might not even work, and you need to spend time on debugging it. And that's actually the case based on the several studies done by different companies. So while there are definitely some pros of using GitHub Copilot and similar tools, like for example, developers reported that they completed tasks faster, they perceived some increase in productivity, and felt more confident about the code, even though Copilot they would tend to produce a lot of bugs. But still, if you look at the bigger picture, at a longer time frame, unfortunately, things like code churn or code renewal rate has increased or even doubled. So basically, the code which was generated by code assistant was either deleted or modified, refactored in the span of 2 weeks. And yeah, a lot of code completions also required heavy modifications from the developers, which essentially means that you are not saving time. You're actually spending maybe even more time on understanding what the hell is even written in this code. Now, why does this happen? Well, LLMs, by their nature, are trying to predict the next most probable token or symbol, and it's all good as long as you work. Your code something that is similar to what was in the training data, and LLMs are usually trained on open source data. So as long as your code looks similar to what has already been written, all good, and you probably will get good results. However, let's imagine a scenario where, let's say you have a unit test written using unit test library, but then in open source data, PyTest is the most prevalent library. I don't have the actual statistics, but let's say for the sake of argument, that PyTest is the most common library in the open source data. Now, when you try to use LLMs to generate a test for your specific code, which is unit test, unfortunately, LLMs will fail because it's so PyTest already, most probable symbol, most probable library, so it will try to use PyTest instead of unit test, and well, you are pretty much becoming not so happy about the results. And things go even worse if you have some sort of your own test framework or whatever your own framework inside your company, because LLMs basically have no knowledge of this framework, and they can't give you any advice on how to use it. They can't even use it for your benefit. Yeah. So, what are the reasons there for current LLMs failing? Well, first of all, they do tend to struggle with some logical reasoning, and they tend to struggle with some facts which might be phrased in not so a straightforward way. So, for example, Tom Cruise is the mother's son. It does sound maybe a bit quirky for for the human ear, but still we understand what it means. Unfortunately, LLMs tend to fail on those sort of quirky sounding things. So in this case, for example, it clearly states that the surgeon is the father's boy, but unfortunately, LLM does fail that saying that the surgeon is actually other father of the boy. And as you can see, it's not even just a regular ChatGPT. It's a O1 preview, which is supposed to be much smarter and much better, and it thought for 10 seconds for that answer, and unfortunately still failed to produce good results. And so yeah, even the latest and brightest models tend to fail, tend to hallucinate, but it just takes them a bit longer than for the regular LLMs. Now, another problem is models don't have grounding in the physical world. And what I mean by that is that they don't know anything about your code base, about your libraries, especially if you have some sort of internal frameworks, internal libraries. They can't check what kind of environment you have locally on your computer, what kind of Python packages, what kind of build to use, and so on. And they can't utilize this knowledge. They can't run those tools, and so on. So basically, you can compare using coding assistants with the case of 50 first dates, or well, 50 first tasks, where you basically take a random person from the street, a random developer from the street. You see him, her in front of the computer, and ask them to basically write a code for you, or solve some task from Jira. And unfortunately, you don't give them any context of what kind of libraries you have. Maybe you have some sort of internal frameworks which you need to use. You have some sort of guidelines and so on. They don't have any knowledge about this. So they already missing some context needed to solve the task. And that's pretty much the case for the current generation of code assistants. They don't have any specific knowledge, specific context of what you have in your code base, in your company, and so on. So they lack context, which means that LLMs might try to hallucinate something, some sort of framework, some sort of function, and so on. And this also produces an incorrect code as a consequence of that, and this makes you as an engineer not so happy. And then you basically do this over and over. Every time you ask the coding assistant to do something, it's akin you picking yet another random developer from the street, sitting them in front of the computer, and repeating this process over and over. And then the last one, of course, as I said, they work well in distribution. So basically, as long as your tasks, or what you're trying to achieve, what you're trying to generate, is similar to what was in the training data, in the open source data, you are golden. But then, unfortunately, once you start importing your own frameworks, your internal company frameworks, everything starts to fall apart because LLM don't have any knowledge about this framework, and it can't properly utilize any maybe functions from that framework and so on. Now let's diverge from LLMs and talk about you as developers. So there was a study in 2015 on how developers spend their time, and who can guess what is the most time is spent on? All right, and work-related? Okay, trying bugs. Reading, yes, exactly. Understanding, essentially. This is what I called understanding. And as you can see, actually editing the code is only 5%. And current coding systems pretty much ignore all the rest of 95% of the time you as developer spend in your work. They just focus on those 5%. So to get a better coding system, to get better help from those coding systems, we need them to focus not just on those 5%, but ideally on all those 100. But already understanding this part of understanding, it will give you a tremendous help because it will also make the editing part or code generation part much better because it will not just blindly generate code, but it will understand why and what it tries to generate. So now let's talk about how we can achieve this. Well, let me introduce the notion of AI agents. So AI agent is a software that basically performs tasks on behalf of the user. And this probably does sound sort of like what coding systems do right now. But what differentiates AI agents is several things, or several design patterns, if you will. Now, there was an interesting comparison of AI agents to Roomba, which can only point to the patches of dirt on the floor, but can't really clean them. And that's not really helpful, right? And that's probably very annoying. So let's think what this kind of Roomba would need to be able to help you to clean the dirt. So if we think about Roomba as a software running on the vacuum cleaner, it also has access to the tools, right? So it has some brushes and so on. It also can do some planning. So it don't just randomly scatters around the floor. It follows some sort of pattern based on the floor plan and what it thinks the best way to cover that area. And those two are already things that can help coding systems, and those two are one of the 4 sort of design patterns. So tool use over here. So first of all, obviously LLM ideally would be able to get some sort of knowledge from the web. It can get some knowledge of your own tools. It can use those tools to get better results and so on. Ideally, we also want AI agent to be able to plan something. It's not just blindly start doing some stuff, but first think about what needs to be done before we can get the results. There is also a notion of reflection. So we don't, again, just get the plan and execute it. We try to, AI agents need to try to understand if that plan is good, if there are any fail points and so on. And we also can have the multi-agent collaboration. So let's say one agent is sort of like backend developer, another agent is front-end developer, and they can interact with each other with the goal to produce the end project end result. Now, let me get back to this diagram. And if we think about those design patterns, we actually can find a lot of overlap with those parts. So first of all, tool use. Well, obviously we use tools for editing, right? For coding, we use tools when we are outside of IDE. We can do some web searches, use browsers, use debugging tools, and so on. And obviously UI interactions also is pretty much a tool use. Now, second part, planning. Obviously, we all do some planning. We don't just blindly start typing something. Even subconsciously, we try to first plan, okay, I will do this thing first and the second one and so on. So we already have a planning here as well. Reflection. We all, well, not all, but usually we work in teams. So we can interact with our peers, we can talk with each other, discuss our plans, reflect on them, and come up with a better solution. And, well, multi-agent collaboration pretty much is the same as working in a team. So we might have, product manager, we have the front-end developer, back-end developer who work together with the same end goal to achieve the best product, I guess, possible. Now, okay, now let's actually do some coding. So let me try to zoom in here. So over here, I have a small piece of code which essentially just queries the model and tries to get some results from it. And this is pretty straightforward code, and all of this code is available online if you want to try it out. I will show the QR code later. But basically, we just start an OpenAI client to interact with GPT-4 model. Here's a small function which will allow us to essentially send our messages to GPT and get results. And let's try some examples. So let's say we want to know what's the response time for Google. In the real world, we would use something like ping. Unfortunately, of course, LLM can't do that. Let's hope the internet won't fail me. And yeah, so as you can see, obviously, LLM doesn't have any access to ping or whatever, to internet connection. So unfortunately, it can't help us with that. Now, let's try another one. So what kind of Python packages I have installed? Again, LLM obviously doesn't have access to my computer, and this pretty much limits its ability to help us with this question as well. Yeah, I don't have access, so pretty much expected. And let's also maybe try asking what's new in Python 3.14. I know this not yet has been released, but there is already 3.14 A0, I think, version available, and with the description of what's new in Python 3.14. But unfortunately, again, LLM doesn't have notion of this new Python version because, and hopefully it will answer me the same. Yeah, OpenAI can, okay, yeah. Yeah, again, as you can see, the knowledge of the LLM is limited to pretty much last year. So obviously, Python 3.14, which hasn't yet officially been released, is not part of that knowledge. So LLM tried to hallucinate something. There is some sort of new syntax additions, which I'm not sure where it came from. And obviously, if you think about how this applies to your everyday life, when you use coding assistants, you might get some sort of hallucinations, you might get some sort of bugs which you might miss when you overlooking the code, and this gets into production. And then if you think about these churn rates and being increased, that's one of the reasons why it happens. And the last one, well, let's see who are the speakers at Pycon Portugal 2024. And again, no information about this, unfortunately. So yeah, not so helpful. Akin this Roomba, which can only point to the dirt. But now let us give our LLM some tools. So what I'm using here is, again, the same, pretty much same client. But now I'm using this so-called React framework. React stands for Reason plus Act. And this framework was introduced 2 years ago. And it consists of essentially us conditioning LLM to follow 5 steps. First of all, LLM needs to produce a thought on what it needs to do to get the task done. Then it can decide which action it needs to perform based on this thought. Then there is a step of pause, where essentially this action is being executed. And after that, there's a step of observation, where LLM observes the result of action execution and plans any subsequent actions based on that. Ideally, it can get an answer, but if not, it might go in the same loop of, okay, so I got those results, now I need something else, and get new action, observe, and so on until it gets the answer. And this can be realized pretty much with this system prompt over here. So this is essentially what I'm asking the LLM to do. You're running this loop. First, introduce the thought of what you want to do. Think about tools you want to use, and then we give the LLM a set of tools. In this case, it's a tool called Ping, which essentially pings website introduced by the LLM. There is Bash, which allows LLM to execute any Bash commands on my laptop, and there is web search, which essentially does the web search and gives the LLM the result of this web search. And I also introduced some example sessions. So a question is essentially a user query. So I'm asking how many islands make up Madeira. Then LLM should produce a thought. Okay, so I need to do a web search. There is an action for web search about Madeira. Then there is pause when this action is supposedly happening. And in the end, LLM gets an observation and hopefully gets an answer, hopefully gets a correct answer. Now, let's quick close a look here. So I have the query model again, and I have those three functions, which essentially do those actions I just described. So ping, it just essentially tries to send a GET request to the website and return the total seconds elapsed from this request. Bash essentially just executes a command, and quick note: don't just blindly execute a command. This is just for demo purposes, but you don't want to blindly execute any commands on Bash, obviously. And the web search, in this case, I just return the first URL from the search, basically, and clean up all the HTML stuff over here. So to remove all the tags and whatnot, just to get the LLM only the text instead of all the tags from HTML. So let me note that, and let's verify that it works. So let's do ping, let's do bash, and let's do web search. So lately, so as you can see, we're using this URL, and here's the text about Madeira over here, quite a long text. But somewhere here is also an answer about the islands. I won't be looking for it right now. Now, we basically just a helper sort of dictionary of known actions. And here where the things get interesting. So this is our query function, which basically runs the loop of React, loop of thought, action, observe, and so on. So it's pretty straightforward. We first query the model with this system prompt and the user prompt, and then we try to detect which action LLM wanted to do. We basically execute that action, get the observation from that action, and then send that along with the previous messages to the LLM. And we do that in the loop, just in case the first iteration is not enough to answer the question. So let us now try to see what's the response time for Google and if LLM will be able to answer that right now. Oh, sorry, I didn't execute the system prompt. My bad. Let's try again. Yeah, so as you can see, it got into the first loop. It thought, okay, I need to execute the ping. It called essentially the action, ping google.com, in the same format as we asked it to do. We ran the ping, we got observation to LLM, and now LLM can answer us our question about what is the response time for Google. Let's check the same about interaction with our environment. So what Python packages do I have installed? Well, in this case, LLM thinks that we need to execute pip list command, which is essentially what it does. So it tries to do the action bash pip list, which returns a list of packages. And let's see. Yeah, we got the answer that we have a bunch of packages, and here's a list of them. And in this case, I won't be checking, but I would imagine that LLM didn't hallucinate based on the actual list of the packages. Now let's check if we can get a new knowledge to LLM, for example, about this Python 3.14. So yeah, it decided to do a web search. And as you can see, here's a link to this 3.14 what's new page. And now here's the observation. It's just the content of the website. There are some new features over here. And let's see what LLM answered us. Yeah, so that was enough for LLM to answer. And here now, OpenAI GPT-4 can give us the exact answer on what's new in Python 3.14, even though the LLM itself was trained on the data pretty much predating any notion of 3.14. And let's check who are the speakers. And again, in this case, we do the web search. Here's the content of the website. And yeah, so LLM can now also answer us the question, answer to us about events happening right now. So essentially, all the speakers over here are based on the website. Now, let me switch back to the presentation. Okay, so as promised, you can find all those notebooks here on this QR code, and obviously you can you can imagine that those actions can also be not just simple functions like bash or web search. They can also be agent on their own, and you can see how it can lead to multi-agent collaboration essentially where a top LLM has a sort of army of agents which are backend developers, front-end developers, managers, and so on. And then each of them is asked to perform some action, and then those actions itself can have some sort of tools, or maybe even more agents under their belt, and they, you can see where it goes. You get this sort of chain of agents, essentially, all working towards one goal, decomposing the task into smaller chunks and executing it one by one. Obviously, there are also some open source tools which can help you, not just define those actions, define those agents from scratch. Some of the most notable ones, some of the most notable open source tools are SV Agent and OpenHands. OpenHands is formerly known as OpenDevin. So you might have heard about Devin, which was, still is a tool which was introduced, I think, last year. And they had a big demo of Devin solving the Upwork task. So OpenDevin, or OpenHands now, is essentially the sort of open source attempt to replicate the Devin promise, but being open source. So of course you can also use those tools to get you started on using agents in your everyday life. But of course, well, we as Encoder, you can. We also give you the option to start using agents without any hassle, without you doing any effort on trying to implement your own stuff. So let me talk a bit about us, about Encoder. So we basically leverage AI agents in the code generation and code assistant way to give you the better results, better code generation. So let's revisit this 51st date scenario, where in our case, instead of just blindly taking this developer from the street, we give this developer a lot of context, a lot of knowledge about your code base, some internal tools, and so on, about your environment, about the environment of your project. And this already leads to much better result in the generations, because LLM now has more knowledge about your code, about your internal guidelines, about your frameworks, and so on. But on top of that, we can also do a lot of agentic improvements. So I will show some demos in a second. But essentially, what we do is we don't just blindly generate the code. We also try to do some checks on top of it. Because LLMs, even though there is less hallucinations, LLMs still tend to hallucinate, introduce errors, introduce bugs. And we want to give you the best compile-ready code possible, which you can just essentially commit to the repository and hopefully not churn in 2 weeks. So yeah, let me give you a couple demos, couple videos. So first thing is unit test generation. And those who tried Copilot, you probably know that you can also, for example, in Copilot, you can ask it to generate unit tests in the chat, and it will start streaming the code right away. And probably even not know in which framework you use, which obviously can be quite daunting. Now, in our case, let me zoom in. Once you click this generate unit tests, again, we don't just start streaming the code right away, like Copilot would do. We first generate what is called unit test proposals, essentially a test plan where we define what we want to test. And it looks something like that. So, yeah, as you can see, you can also edit the test cases, or you can add your own test cases in case you want to test some sort of specific corner case, which we didn't cover, or maybe you want to test something specific, some sort of specific value. Now, once we hit start unit test generation, again, as you can see, we don't just stream the code right away. Obviously, we do generate the code over here at this step. But then we run what we call a repair pipeline on top of that code to make sure that it actually runs, it actually compiles, and basically that code that makes you or your unit test happy. And yeah, you can see we do some syntax checks, we try to run it, and at each step, we try to fix errors which might arise, so that in the end, we get the unit tests which actually work and which you can actually use and commit right away. But that's obviously not all. You can also leverage this repair pipeline, those repairing agents, in code editing or code generation features. So, for example, in this case, I have this code improve feature, which essentially you can ask the encoder to optimize or edit your code in some way you want to, So in this case, I have this extract claims from JWT function, which is written basically using built-in libraries, base64 in JSON, which I guess is fine, but we can also rewrite this using JWT library. So we can use library specifically designed for working with JWT tokens. And we essentially will ask the encoder to do exactly that. So let me just pause here for a bit. So yeah, we're just asking to write the code using JWT. And once we hit enter, again, as you can see here in the corner, we don't just generate the suggestions. We also, once we get the code, we also try to repair it. So we try to run it, we try to do some syntax checks, and so on. And in the end, as you can see, we removed unnecessary imports because we no longer need base64 and JSON libraries. But we need a new import for JWT library. Oh, sorry. And let me scroll back here. And the function which we initially tried to optimize is essentially now a one line of code, which is much more maintainable and easier to read and understand. Okay. Now, what's next with all those new tools coming up? What happens to you as a developer? You've probably seen some headlines that this tool will now replace all developers. Nobody should go into IT and so on. And that's one way of looking into that. In some cases, it can be a good thing. In some cases, it can be a bad thing. Because there is a lot of hate from artists, for example, about AI tools. For programmers, it's depends. But I mean, even if the ChatGPT will replace us, you can always go goose farmer. And I guess that's or whatever your heart tells you to do. But not everything is so gloomy. So obviously, first of all, the model can't work without data, so you obviously always can try to generate data for ChatGPT, generate training data. But seriously, I think the better way to think about this is you would not just be using some sort of tool; you would be collaborating with it, right? So as I mentioned in the example, when I showed some code. You can imagine that you have some sort of army of interns or junior developers who you can ask to do some sort of mundane tasks on your behalf, or even better, you might have some sort of even full-fledged company consisting of managers, virtual company obviously, consists of managers, developers, DevOps people, and so on. And you can ask them, you can delegate to them any tasks you want, and they will essentially collaborate with you on maybe defining some requirements or updating them, and in the same time executing the code, creating the code so that it fulfills your initial task. Yeah. So again, our tool is currently in closed beta. We will go public in the next couple of weeks. Until then, you can join us. You can try us out using this QR code over here. Join the waitlist, and I will make sure you get an invite. We also have a booth on the left of the auditorium, and you can find me or my colleague Artyom. We are pretty noticeable, and I guess that's because of the color of the t-shirt. Yeah. So I hope that was helpful for you, and hope that it helped you understand that we won't get replaced anytime soon. And yeah, happy to answer any of your questions.
Thank you so much, Alex, for the talk. Oh, no. Some hands.
Thank you very much. That was so cool. You blew my mind. I've been very skeptical about all these chatbots, but that was really cool. Thank you. I noticed your research was from 2015. I mean, the cynical part of me was like, well, that's just classic AI companies looking at stuff. But it's quite old. You know, do you not think things have changed since then, programming over the last 10 years? Yeah, that was my question. Thank you.
Yeah, that's actually interesting because just yesterday I saw a new study which said there was a company which essentially asked around, I think, 800 developers to use Copilot, and they compared their output for 3 months before using Copilot and then 3 months of using Copilot, and they didn't find any benefit whatsoever from using Copilot. Essentially, they didn't work less. They didn't produce more code, they didn't produce more pull requests, and so on. But at the same time, this article, they refer to another company which introduced GitHub Copilot, or maybe it was some other coding assistant, regardless, and they saw indeed the boost. So, there is still some evidence for and against, and I guess it also depends on how you use those tools, right? Because essentially garbage in, garbage out. So if your request to LLM is not so good, maybe you just asked it, with one word. Obviously, it won't be able to help you. But if you write a better prompt, if you write a better, question to the LLM, it might get you better results. Or in the case of Copilot, better code. But again, still, kind of prompt engineering is essentially in a bit of art. And if you want to get the best of those tools, you need to kind of master this art, in a sense.
Hi. Hello. Is this on? It is. Hi. Fascinating talk. You kind of half answered my question just now, but I was going to say that it seems that a lot of our job in the future is going to be prompt engineering, in which case the quality of the code that's produced isn't so much down to the LLM, but down to the skill of the person prompting. And there have already been studies made about this, where if you give inexperienced programmers an LLM and they ask stupid questions, you're going to get stupid code out. Exactly. Well, anyway, there's still going to be a human in the loop to make things difficult. So my question was, and you kind of touched on it just now, you talked about the quality of the code. How do you judge that quality?
That's a good question. And there are some tools where you can which you can use to assess quality. And there was another, again, study, I think a couple of years ago, where they tried to classify the code based on how hard it was to modify the code to get into production, like how much time it took the developers to modify that code, to push something, to create a pull request. And based on that, they essentially this research introduced a tool which was based on code smells. You probably heard about code smells, so like complexity of the code, like a number of branches, or in the if-else statements, and so on. So that's one way of creating some sort of metrics which can check the code. Another option is to use another LLM to check if the code is good or not. Obviously, this is still prone to errors as well, or hallucinations, but that's one of the current sort of directions, so-called LLM as a judge, where you can ask other LLM to assess the output of the first LLM and see if it's good or not. And yeah, speaking of the jobs and the future, obviously the job of the developer will sort of shift more towards reviewing the code generated rather than writing it. But it doesn't mean that you don't need to be a good developer to properly review the code. Right? Because if you are not so good developer, if you don't know how to code, you can't properly detect bugs, you can't properly detect errors and whatnot in the code. So I don't think it would just boil down to prompt engineering, right? Because you still need to overview the results of the code as well. And indeed, the human in the loop never say never, but human in the loop will still be there for some time, obviously.
Hi.
Hi.
I didn't saw the whole presentation, sorry.
Okay.
So I might be missing something. Okay. but it's about references. So what I mean is you have a methodology, which is quite interesting, right? Because you have URLs and all that stuff. And sometimes you get code out of nowhere. But that code comes from somewhere, right? You rationalize over it, be it Stack Overflow or GitHub. Do you provide those references to the programmer? Because I can imagine, and with the human being in the loop, right, you can go back and even grab some more context, because the context you presented, it's interesting, but it's not presented in your tool, I believe. I didn't try it. So do you give those references something you were thinking adding, or?
Yeah. So we don't do that right now. We did discuss several options on that regard. So, for example, things like checking that the code falls. Well, if it's the same code as the open source code, checking if the license is good. If it can be used or not. Right now, we don't do that, but that's definitely on our roadmap. To give you better information that make you safe, feel more comfortable using it. Because obviously you don't want to get some sort of code which is licensed under, copyleft or whatever license into your code base, which can imply, sometimes bad things, right? And that's definitely on our roadmap. But right now we don't, provide any reference.
Hello.
Hello.
Thank you for the presentation. Considering traditional machine learning algorithms, that if you train them on predicted data, they'll start losing their quality. And considering these algorithms, these LLMs rely on scraping the web. Currently, we are seeing some websites closing their doors to LLMs, and we also see a huge influx of low-quality answers that are written by bots, commented by bots. If you go on Google Images and search for baby peacock, you just see AI-generated images. What do you think will be the future of these algorithms as time goes on, as the internet starts to become garbage?
Yeah, that's a good question. It kind of partially goes beyond the talk, but there are obviously some recent studies which you can find where they sort of check how the quality of the model deteriorates or improves based on the training the model on previously generated data versus training on the human-generated data. And indeed, model do deteriorate in quality even quite significantly if they get trained on the data which was predominantly generated before them by another model. And I think that's another sort of part joke here. That obviously, LLMs right now, at least, they can't produce code completely from scratch, right? You still need to have some sort of human in the loop, and you can think about this in several ways. It can be something more simple, like simple labeler jobs, but it can also be something more sophisticated, like writing the code from scratch, more complicated code, and so on. And I think in the future, indeed, we will have a problem with this data being more and more generated rather than genuine data from people. So yeah, I think we will need some way to sort of get this data filtered out first, and then get better, higher quality data, which can also be part of the this human in the loop notion, where people generate data and LLM use that data to give you much better results and much more data.
Thank you very much. It was very interesting. I really enjoyed also the initial part about the agentic patterns, and that was very clear. One thing that I noticed by using some of these patterns is that so some of the limitations are mostly on the side of performance, and especially when using third-party services, is about like getting throttled because at the moment the rate limiting is insanely low for most services, and they provide you with like some things like, I don't know, interregional ping pong or stuff like that. However, I mean, making so many LLM calls can be seen as a limitation of the pattern. So this is just a curiosity. What do you think what is the way forward? What do you think is going to happen to mitigate that issue for any non-trivial use of the agents?
Yeah, that's a good question. And I guess there are two parts here. So first of all, obviously you can use local models as long as your hardware allows you to do that. Like on some modern MacBooks, you can run Llama 70B, I think, or 34B, which can produce decent results. They won't be as good as ChatGPT, right? But still, it will be run locally, and it will probably might be much cheaper. But at the same time, if you look at how the cost of running LLMs progressed and how the models progressed, you can see that the cost pretty much reduces in half every half a year, right? So if you compare the prices right now for ChatGPT versus the prices for GPT 3.5, it was quite a big difference. And the current model, it runs faster, it runs much better and gives you better results. So if the trend continues, we will see much more powerful models, much faster models, even on the server side, but which will be still cheaper, and you will be able to use them much more frequently. So I think going forward with this trend, I think this should elevate the issue of a bunch of LLM calls indeed.
Cool. Any more questions? No? Yes, that's it. Thank you so much for the great talk. I really like the memes. And for the next talk, talking about comparing time series forecasting models, a clustering analysis approach with Python, I would like to invite to the stage Alexandre Oliveira.
Olha, preciso de ajuda para ligar o computador. Já pôs aqui a Como é que a gente liga isto? Só isto. Só isto? Sim. É das todas? Isto tudo. Tens aí o clicker. Pronto. Queres o microfone de mão? Faz isto. Acho que não sai daqui. O clicker está aí. Tens o laser aqui. Se queres apontar. E aqui para a frente e para trás. Uhum. Faz-me sinal. Está aqui todo. Olha, acho que não está. Está? Good morning. So I'm Alexandre Oliveira. I'm just a little bit of my background, so to have a better context about this talk. I am a data scientist, but also I am a professor at Polytechnic of Porto. Sorry, my bag is hitting me on the leg. I'm a professor at Polytechnic of Porto. I work a lot of my years in health sector. It is a particular kind of data. And today I'm talking, showing you a little bit of the data science project that I did in the collaboration with colleagues, some colleagues of mine and a student. My student is finishing his master, her master. And this is a little bit of this work in time series that is a special kind of data. So today I'm going to show you a little bit of the time series clusters, the problem itself. What kind of data is this? What it brings special to this context? The problem itself, what we were trying to achieve, what trying to learn, and the approach that we did, and some results and main conclusions. So let's start with the problem. What we're trying to achieve, trying to model. We're trying to model the years lost due to a severe illness or early death. That was our key factor, our outline, our data, that main concern that we're trying to model. Just a bit of context. What you are seeing here is the burden of disease due to several kinds of diseases. In blue, you have the disease non-communicated, such stroke, diabetes. Most of these diseases are linked to habits, and then they could be changed and bring better health to the communities. In red, you have community diseases, the infectious diseases that transmitted person to person, and they are out of the scope of this project because they are really difficult to model. And in green, you have accidents, falls, self-harms. Therefore, what you can see from this chart is that the burden of the disease due to non-communicated disease is large in all countries of European countries. So this is the cumulative for all the countries in Europe. So we were trying to see these communities, and we start to think if what is happened here, all the countries are the same, what will be the future? And that was our questions that we tried to model. Will this burden of disease still be the same in the future? All the countries are the same. Can we cluster or group countries that have similar patterns? So that we are able to predict the future, we need to know the past. So, and need to focus on the most important things and informations. So, in this image, what you see? If you focus on the light patterns, you will see a skull. But if you focus on the dark ones, you will see devil kittens. So, the information that we focus will bring us new information, will bring newer ideas, will show different patterns. If you have this kind of information, what is similar? What will be the most similar objects that we can group? Which groups will be needing to do? So we use this law of similarity, and we're trying to see, of course, if you focus on the shape, we'll need the clusters of the squares. If you focus on the triangles, we'll have another groups. If you focus on the color, we'll have another group. So different groups will be different solutions according to the criteria that we need to focus more. And if we have time series, a time series, I don't know if you are familiar with the terms, but a time series is a graph, it's a line that shows the patterns through the different years. Here in these charts, you have each line is a time series of the burden of the disease, a particular one, these cardiovascular diseases that we choose to model and to show to you, represented in the country. So what we see in this chart that is there tends to be a cluster here. It seems for me that these lines are grouped together, but we have different patterns and different lines that we don't know how to cluster and to group. And we don't focus on the whole time series and focus just in some characteristics of the time series. Maybe the trend. Here we have some different trends. Each of these graphs is a trend for a particular country about this disease that we're trying to model. It is better to cluster these trends despite or these ones. What would be better? What groups can build upon these trends? But if we can compare two trends of similar patterns, how can we group new groups? Given a new time series, which groups should we cluster in, include this pattern one? The final key is, what is a good solution? What is a good solution for a cluster? I don't know if you are very familiar with the clusters, but cluster is an exploratory approach. So sometimes the clusters are natural and we can create groups of similar and homogeneous things, objects. Sometimes they are not, and they are somehow heterogeneous. So the time series clusters focus mainly in 4 keys. That is a representation of that pattern, that line, the way we consider two lines similars, the way we group and form the time series, the groups of time series, and finally, the way we evaluate the solution created. Cluster is a group is included on non-supervising algorithms. So we just need input data without label, of course. And there are many approaches available: hierarchical, k-means, and principal components. The main use cases of this approach are recommended systems, the anomaly detection, cluster segmentation, also to prepare data to other analysis. So this approach is based on 4 key aspects: the representation methods, the way we are providing the information to the algorithms. And here we have a lot of approaches. We have standardization, dimension reduction, univariated models, also smoothing, fixture extraction, and also business rules. We can focus in several key aspects of that time series. In terms of similarity measures, we have several approaches also that can be clustered in 2 major keys. The first one is in time or shape, when we have the most famous Euclidean distance, so dynamic time wrapped, and also some distance or similarity measures based on models, such as Piccolo, Maharaj, and LPC. In terms of clustering approaches, the way we form groups of things that we consider to be similar. We have hierarchical, partitional, and hybrid approaches. In terms of evaluation, we have silhouette, Macaulay-Kelsey, index, Dunn, and business rules. So the combination of these four key factors will produce different groups or approaches. For this talk, this is a large world of time series clustering, and I focus here in some specific parts of these 4 key indices. In terms of representation, we will approach using univariated models, the distance based on those models, the hierarchical, and then all the measures, because of course they have different approaches and different strategies. Why we are doing this? This approach is model-based and univariation models representation allows us to see the future and to try to group time series with that in mind. What will happen, not what we observed here in the present or in the past, but what we could do in the future. So to do this, what was our approach? We collected data from a public repository, and then we prepare, analyze, do the exploratory data analysis to try to identify missing values or outliers that might introduce some noise in our approach. Then we fitted ARIMA models. I will not discuss in detail this fitting approach. If you like to know more, then in the coffee break, I'll be happy to discuss with you this ARIMA approach. And then use the parameters of each model to cluster or find similarities between the time series. Use several techniques of clustering, all within the group of the hierarchical clusters, and then evaluated with all the indexes that were available to try to find a consensus of these groups. How did we do this? We use a lot of Python packages from the stat models and PDR-IMA to find the best models to represent each time series. We use tsclust and then scikit-learn to fit the best models. Use tsclust, PDR-IMA, and bclust. And bclust was to find the best to evaluate the solution of clustering, and then pandas, numpy, seaborn, and matplotlib to represent the information. So for the disease that we are trying to model, that was cardio, we are expressing here in this presentation, we obtained a lot of models. We obtained each model for each country. Of course, these RMA models are very different from each other's. They are simpler models represented here in Denmark. We use a little bit a light model, but in other countries we needed a more heavy model to try to describe the patterns that we were observing, such as the ones in Austria and Azerbaijan. We evaluated each model with 5 evaluation metrics: AIC and ABIC, that is amount of information that model can capture, and then the traditional maze, RMESEA, and MAP. Here it shows to fit or focus on the map, because we have a lot of countries, a lot of time series with different values, with different approaches, different trends, and map allows us to better compare each model without the influence of the values itself. What we find in this way is these simple models, univariated models, are better fitted to countries like North Macedonia and Azerbaijan, and ill-fitted, not poorly fitted, not ill, because they are good models, but less good models to describe the patterns observed in Denmark and United Kingdom. With these models, we choose 3 different similarity measures. The Piccolo, it is a measure similar to Euclidean distance. It's inspired in the Euclidean distance, but applied to ARIMA models. We used also a Maharaj and LPC, and we explored all solutions between 2, because one solution, one cluster is pretty inefficient, and 15. We explored these numbers and tried to be between 2 and 15, what would be the best number of clusters. This approach have 2 objectives. The first one is to find the best number of clusters that the data allows, and also evaluate the final solution. Because when we look to the patterns that I showed you before, we look and we don't know how many groups we could extract or would be needed to extract from that kind of data. So with these three distances, we use all the clustering techniques that were available: the word, the complete, the single, the average, the centroid, and median, and all the available indices to evaluate the solution. What you are seeing here is the best solution for this index and this method. So the word method for the McLean, according to the McLean perspective, would be 2. Then for the C index would be 15, with the silhouette would be 15, and also with done would be 2. What we do with this lot of numbers for every approach, we focus on each approach and selected the majority of votes. If, for example, for the word and Piccolo distance, we would find 15 clusters, the best solution that would be available for this approach. And then the complete, the single, the average, and their forth. What we're trying to see is what is the influence of the distance on this creation of these clusters, and also what was the influence of this method. But of course, different distances have different solutions available. And then, but what would be the groups that was formed later on? So here you are seeing the Piccolo distance. Just focus on the Piccolo distance and the several approaches that grouping approaches that were fitted. So here we have the Piccolo distance with the word method, the complete linkage, the single, and their fourth. What we are seeing here, traditionally Piccolo gives a lot more clusters than the other distances and a lot of heterogeneity. There are some patterns that can be extracted in this award method and the complete linkage. It tends to be a group cluster here in the east. And the single method and the average method typically cluster all the groups, the countries together, and leave Latvia alone from some reason. Let's see the patterns with another distance. Here we have the Maharaj distance. And what we can see at this method, the word and the complete, always trying to extract a lot of clusters, but the others groups, algorithms, techniques, typically cluster a large group with all the countries, and again, Latvia alone. And this is also true in the last distance. The last distance, also the typical these algorithms leave Latvia alone, and then there are 15 groups a little bit different. What were the main findings? We saw cardiovascular diseases, of course, but we saw and analyzed a lot of others. And what we learn about these clusters, about the non-communicated diseases in Europe. In terms of the diseases itself, we learned that countries with similar diseases progression patterns tend to cluster together, revealing shared health factors like healthcare systems that are similar, environment condition, and social economic influences. Austria, France, Greece, Ireland, and Spain frequently across all non-communicated diseases were grouped together. Latvia, Poland, and Greeceland often form distinct clusters away from the other countries, indicating a unique pattern, health patterns, or even a unique health system or reporting notification system. Countries in the same region, Western or Eastern Europe, frequently cluster together due to shared policies and lifestyle policies. In terms of impact of distance and clustering algorithms, distance measures sensitivity. Clusters outcomes are significantly influenced by the choice of distance measures, which capturing different aspects of the data. Some focus more on trends, others tends to focus more on seasonality, some are sensitive to noise, and others are insensitive to noise. The clustering methods, of course, form different clusters. It's also are sensitive to the distance, but also to the time series itself. Countries with similar, in terms of ARIMA models and public health implications, countries with similar ARIMA models behaviors may benefit from shared health strategies and collaborative research. Countries in unique clusters may require tailored interventions due to distinct disease dynamics. So that's all. And I don't know if you have some questions to me.
Hello.
Hello.
Thank you for the presentation. In the beginning of your presentation, you mentioned that modeling infectious diseases was really hard. Why is that? And also, how are you getting the data for this project?
This project,
Yeah.
the non-communicated, is a public repository.
Yes.
Is HIMEA. Yeah, then I'll give you a link if you like.
Okay.
Diseases, communicated diseases are harder to model because of the interaction of the individuals. It's hard to model and to capture the number of interactions that are available between people, and it cares a lot more of data. We need more data to try to analyze and predict what will be the next number of infectious diseases.
Okay. Thank you.
You're welcome.
First of all, thank you for the presentation. It was really interesting. I have 3 questions, but
Okay,
the first
we have
one,
time.
the first one, what's the period for the data?
Yes,
But-
yes. It goes real fast. The data was available since, let me just show it to you, since 1990 until
okay.
the present.
Okay, but the question is, it's grouped by year, by month. Because the first
year,
by year.
year,
Okay.
yes, okay.
The first question is: are you concerned about some seasonality? For example, if we talk about heart disease in December, in Catholic countries, we have more heart attacks.
Yeah.
For Christmas, for example.
Oh.
When comparing to other countries and other cultures. And are you concerned about this trend or this kind of seasonality?
We are not able to see the seasonality in terms of month because we use here data, but the models itself can capture the ARIMA, and the ARIMA models can capture seasonality and trends real nice. Yes, that kind of patterns would be imprinted on the models itself.
Okay, the last question. Did you check about other social information, for example, culture, for example, social index from the countries to see any kind of trends that are not considered only on these numbers, on these rows?
No, we were just using the time series itself. We were trying to model in a lightweight as possible, try to see with the lack of data what we would be able to achieve in the end. So, of course, this is the preliminary study which could benefit all other contextual data about the diseases itself.
Thank you very much.
You're welcome.
No more questions? No? Thank you.
You're welcome.
Now we'll have the coffee break. That will start now. And we'll come back here at 11:30. Ok, tá bom. Okay. And now we'll have Caio Salgado that will present us a talk about the evolution of crowd typing.
Hello, everyone. Can you hear me? Yeah? Okay. So just a couple ground rules. If for some reason starting to speak too fast, you guys like make like this. For Kenneth, talk slower, okay? So let's make a quick test. So if you talk too fast, you guys have to do. Okay. Thank you. So are we typed yet? The evolution of gradual typing in MyPy. Let's see. So who is speaking with you? So my name is Caio Salgado. I'm a backend software engineer. I have been coding for my life for living for the past 10 years, more or less, a bit more than 10 years. Currently, I'm a developer at Exonius, part of the developer. I live in Porto for almost a year, but if you can check from my accent, I'm from Brazil. Anyway, so a little bit about myself is that I never liked static typing. So I'm doing this talk, right? Actually, I recently started to like static typing, right? So during my career, first I started with C language, and it was horrible. I cried. It was not nice. A lot of types, not much help, and I almost gave up. But then I found something better. I found Perl. No types, no nothing. Lots of fun, lots of errors. But then I found something even nicer. I found Ruby. That's for me. I was very happy. I was no typing again, and lots of things to do. And if you see I'm going in a nice direction, where can I go next? And I went to JavaScript. And that was not that fun, but it was crazy. Lots of different things, a lot happening at the same time. And from that, I went to TypeScript. And TypeScript, there were some nice things there, some interesting things. And by the time you might be thinking, oh, I touched some languages, but where's Python? So I always touched Python. Every time, there was also a bit of Python everywhere, doing something like with pandas, data science, or scripting, or something else. So finally, now you see I'm happy because I'm only coding Python, and that's nice. Okay, so we are talking about types, right? So I was working with TypeScript, right? And what's nice there is that I had this whole idea of code completion. I don't know the APIs, I don't know everything. I have an idea, and the idea to dot and autocomplete. I open brackets and I see all the options. Here now I'm scrolling up and down, and I can see the different signatures of the function. I don't need to put a keyword argument here. I know every time I type, the IDE, in this case VS Code, is telling me what I'm typing, what it is, right? And actually, VS Code is from Microsoft, TypeScript is from Microsoft, so they made the integration awesome. So it worked very well right from the start. This idea, I don't know the documentation of Luxon, but I don't need. I just go typing and I go testing. This, for example, this fetch, right? I write fetch as a JavaScript common API, and you can see there's even the MDN reference there. So if I want to know documentation, just click there. It takes me to the website. Here, even this API, and something interesting here is that I know the types, I know the name of the things, but for example, here I'm making a request to the weather.com that doesn't make much of sense. And it's for instance, today, I look at the different functions. Oh, I want ISO something. I just type ISO, it autocompletes fuzzy finder. It's awesome. So I get everything. And here, for example, I get this wiggle line. I hover it, and I can see, you're calling a function. So, okay, this doesn't expect a function. Let me put brackets. It even suggests to me, hey, put the brackets. So that was nice. Hey, this is a very nice thing that TypeScript has, right? This is cool, right? Never saw this before. What can I get from there? Nice. So that was a very good experience I had. And okay, how can I get it more? How do I want that, right? How can I get it in Python? And yeah, here is something very nice. For example, I'm typing process. I see the other options. I say, hey, I found my library too. Automatically imports for me right? Then I open brackets and say, okay, process data waits some list of integers. Okay, let me give you a list of integers. And what is the result? I don't know it. Let's check. I type the result and result and see, okay, oh, I just opened the call and see, oh, it's already give me options. So, okay, so give a list of numbers, give me the totals. Oh, it also gives me the average. So, oh, let's make some calculations. What else can this do? Oh, there's a fast. Why not? Fast, true. Fast is a Boolean. I want this to be fast, right? I don't know what it does, but I want it fast, right? Okay, so I get this completions. I get in these types. Like, I don't know what process type does, but I can see and I can navigate it with like kind of errors. I'm looking a lot through the signature. I found there's like some extras there. Okay, let's try that. And I just type extras. It opens up. So I open the brackets and it adds from like median. Oh, so nice. So I can also get median. But that was not there before. Well, how come? Okay, now it is. So I add extras, I add median, and like this whole environment that I'm in tells me, okay, now you have median. Awesome, that's nice. But what is the type of median? Like it has to be float, right? What it is? I just type a something, any variable, and I can see the type. So awesome. But what if I remove the median, right? Squiggle line. So okay, right now, like I'm not getting the error, right? So not getting it, like the IDE is telling me, hey, this variable does not exist. It depends on that thing there. So that's very nice. You can see this dependency, and you're like, you don't know the API, you don't know things, or if you're playing around. That's a nice thing to learn. I love to do that to learn, like playing around, try things. And the IDE gives this quick feedback. I didn't run any code yet. I'm just typing, and I can see what's going on there, right? Yeah, for example, that's the surprise. I just type it and say, hey, surprise is not a required key. So actually, all the time, I'm using a dictionary. Result is an ordinary dictionary, right? But I type it, it has a lot of, and again, like I just type user, red line. I get like, what it is there? There's age, okay? Age is red, so everything's red, okay? Age is not known, attribute for none. Okay, so user might be none. It's different because this time user is a identity model, right? So the errors are different. So okay, let me work inside a block again, so I can work like this won't happen because I'm sure the user exists here. And also I'm using Pydantic. I'm using a lot of that Pydantic does some runtime checks, and also is lots of types there to help you. And I can just like go around and see the user. Like, hey, the user has last name. Also something nice I noticed here, like there's name and there's last name. Like that's kind of bad, right? So I can just hover the name. Go, for example, to here, just pass like F2 to rename. Like I'm using Copilot, he also gives me some options. And I just, hey, I changed the name, but what about the API? Like I changed the usage, what's there? So I go to the definition, and in the definition, I find the user profile. Inside the user profile, I can see that it changed the first name there, right? So given I'm using all these types, and there's all the things inside, in this case, PyLens, all this infrastructure, I can change types. I can like change an attribute, and it changes everywhere. It finds all the reference to it and changes all of those. And also, again, I have some navigation inside the user, because user.makeaccount.cards, and so forth. Nice. So that's awesome, right? Why I want that, right? That's great for me to get things. And you see, like one of the biggest things here, the biggest wins I have here is the new Python. New references, right? There's this guy like Tony Howard. He's the guy like who invented Quicksort. The guy who invented Quicksort. So he had this talk in QCon. I believe it was in 2009, right? And one of the main takeaways he gave here is like, this is interesting. Like this is my interpretation, but like new pointers, like you're giving a freedom to the user. Hey, like this is easy to code, easy to give. I'm gonna give you this freedom that something might be there or might not be there, and you go and handle it. It's easier. But it's points like the user, the developer, doesn't always like is right? He doesn't know. I need to give him boundaries. I cannot give you the freedom, right? Sometimes I give this freedom, he doesn't know how to use it, and lots of issues happen, and you get like the $1 billion mistake of having no references. I don't know. So okay, how does can you get Python to take it? Like how did you make Python get these types? How does that work, right? So I found the history, and you have to start small, baby steps, right? We may fall sometimes, but getting these types correct. So I do a little digging, And back in 2006, I found for Python 3.0, the function annotations. It's just like, hey, this is annotation. This is not like typing of that. It's just like we want to, how was it? We want to provide a single standard way to specify information, like annotation, like how to do it, right? I do a little dig, I don't know exactly how PEPs work, but I found the commit that changed the state to accept it, and it was 2007. So create 2006, approved 2007, and 7, 8, 9, 10, 11, 12. 5 years later, 2012, I found this first commit of MyPy, right, in GitHub, from Yuka, probably saying his name wrong. And the idea was like MyPy is that MyPython, right? It's MyPython. And they started Yuka create like I'm creating a new adapter for Python, a new interpreter for Python, right? And it's going to be a different language, right? That's going to work similar to Python. And I did a little more digging, and I found that in his blog, like not digging, but just clicks. That 2 days later, he created this blog post and created the first one. Hey, like I'm creating this. I'm using this post to update it. And then I took a look at the history, like he made some posts there. And this was 2012. At 2013, he went to a PyCon California, and there he met Guido and Army Ringo from PyPy, had a lot of talks, and said, hey, like, PyPy is awesome. And you know, you have this annotation thing that we don't use, so perhaps you can use MyPy to use that. By the time, like, MyPy was not, like, conformant. I'm already 2 minutes in, there's a lot in, so I'm gonna go a little bit faster, sorry. And a couple more times later, they got the PEP for type hints, right? The draft in 2015. An idea in MyPy, like the main guy there. And that's it. Like we got MyPy, we got typing, and that's also like I'm gonna concentrate everything on MyPy. But other companies were there. I saw this podcast with Guido, and there was Lex Friedman, and he said a very nice quote. It's like MyPy being an open source project with a very small number of maintainers was successful enough that people said that the static type checking stuff for Python is actually worth investing for our company. But somehow they choose not to support MyPy, making MyPy faster, say, or adding new features to MyPy. Both Google, Facebook, and later Microsoft developed their own static type checkers. So we got Google with PyType, we got Meta with Pyre, we got Microsoft with PyWrite, right? PyWrite is the one I'm using there. That's cool because, like, if you open a Python file, say, hey, why don't you use PyWrite? Like PyLens, that's PyWrite, but plus a bunch of things. So we get 4 type checkers, 3 made by big techs. Like, that's all type checker we need, right? No. First thing, like, some people may be saying, hey, I don't use types, and I have all these features for some time. Because, yes, like, if you use PyCharm has a lot of different things there, and he does also works a lot with, like, trying to infer types, trying to infer what you're doing, and how different things work, right? I found the other guys also, I'm not going to talk about it, but it's based on MyPy is a fork of MyPy. There's PyLizer, also a different one, and why not do it in Rust, right? Everything's in Rust. So there's also PyLizer, right? Which, since it's Rust, the page I would say, hey, I'm the fast one of all the type checkers, and okay, that's nice. Demo, do you have time? No, there's no time. Okay, so adoption, like that's the talk. So I found this article. This is from 2020 about like the usage of the types, and it looked at like 20,000 pull requests, repositories on GitHub, open source, and here's some data from that. From all the things that are typed, most of it, the majority are user defined, so they're classes that users define them, right? Then like have stir, none. Basic things, and you can select the most one is complex. So most things that are typed either things that people created, right? Developers created. And from where is all this typing? If you can see there, that's the returns, the parameters, and the assignments, right? The assignments is very little use. Most of things in params, except none. There's one thing of MyPy, like at least in VS Code. If you have a function, but you don't type the return value, MyPy doesn't ignore the function. Okay, I want to look at it. So if you just type none, then you get all the type going there. So that's my guess for why there's for none there's so much typing in returns. And this is the hard truth, at least from 2020. The logarithm scale of the number of files, right, with annotations. As you can see, the huge majority has 0, right? There's no typing at all at the file. And that's smaller and smaller until you have like a bump in the ones that have plus 100. Right? So the majority of code, I can say like there's very little type or no type, but there's in the end, like there's a lot of people that use types. This is for repositories, right? So from 2678, and again, like you can see more clearly, that's some guys has a lot of typing, right? So I want to reference here like a nice, very awesome book that I read. I'll give you some ideas on that. This book from Luciano Ramalho, Fluent Python, and going very quickly here, he gives like this idea of duck typing, goose typing, static typing, and static duck typing. That's something new, right? Python started with duck typing. It's like, what is that? Like, I don't care. Like, if you do here, there's no. I can call alert with any of the instance of bird, instance of duck, instance of goose, and there's no syntax error. The code will run, but you're gonna get a runtime error. It's only in the runtime is gonna have error, and the idea is that you just need to if you have this function, if it works, that's it. In 2.6, we got goose typing. Goose typing is like, hey. For example, here is the tree of inheritance here. So, for example, if I want something that is a container and I have something that is sequence, I like say something inherits from the different one. He say, okay, so like the duck is the sequence inherits or the way around from container. So I know like a container behaves as sequence. So we have this goose type is 2.6. And here's an example. For example, the bag is a sequence, right? And since it's a sequence, I can use how big I am. It's going to go len. To be a sequence, here the only construct methods you need to implement is get item and len. So you get these two. So I can run an interval if it doesn't implement inter, but it has get item, so Python handles it, so that's nice. Then we have static typing that we start from 3.5. And here, for example, I can see like, hey, I can strictly give the type, and I can before compiling, right, the type checking can tell me, hey. We have an error here, like it does not work. And in 3.8, we got like the static duck typing. Is like you have duck typing, but you like tell it. You make it explicit. For example, I'm telling, hey, there's things like the support quack, right? And they just have the quack method. And then everything that you can say like you can type it with support quack. So anything that has that method will be a duck, right? In this case, support Mac. It doesn't need to have that inheritance chain. Okay, and that we get some bonuses. For example, here on the right, I can add like this runtime checkable in the protocol, and then what I get, I can do like existence. So something that's completely typed, right? There's no like value there, runtime value. Now I can do like this instance check, right? And for the other way around, I can say, hey, get item, so I can type it now. I can say, hey, this is the size, this is the interval, yeah, and this like works for the abstract class, right? But you see that there's a strict line there, so there's some issues there because like it works. I run this code, it works, but my Py cannot tell like because that bag is an interval because it does not implement inter. But it doesn't matter. Like Python, if it sees the object has get item, it will behave as an interval. Like it does that. So my Py is not there yet. So one thing that is brought in that book is that sometimes you need to know like Py type ignore, right? Because it's not there yet, right? It doesn't run a function. And okay, something very interesting there that he brought also was that the typing of max function, right? Max is a simple function, right? It just give an interval, right? Or just give like two or more arguments, and you're going to give the maximum there, right? There's also the default value and the key, the function to run it. So it's kind of easy. Like if you see this, you already know like the API, right? Max for tree, max I can pass a function to get, so I like inverted it, and I have a default. If I get an empty list, I get the value that I set at the default, right? So let's type it. This is the typing. just the types, not the implementation of the max function, right? I got it from the book, and you can see like we have this dynamic nature in Python, like for the max, it works in different ways. And if I want to type it, this is all the code the amount of code I have to work, right? In order for that to work. For example, you don't see the missing or empty message being there because for default you can have anything. And how can you tell anything from nothing? So it creates this missing object and it compares, hey, did I receive, do I have missing or not? So do I have the default or not? So this is what you have to do. So one of the idea that Luciano Ramalho brings is that if you start using, or if you want to have static typing and everything, that's going to change how we write Python, right? That's going to change all this dynamics, everything I can do with that, right? There's this quote about like, although it is hard to express the signature of max, it fits one's mind quite easy, right? In my understanding, that expressions of annotation makes it very limited compared to Python. So the annotation, how to express it, is not good. That's their point, right? Because that's make you code different. Like that's, you want to have a max. You have to type everything. There's a terrible example of showing that is the request library, because request, like, it's awesome the way it works, the API. And one of the parameters of requests is the files, and this is the piece of the files that I look there, like to implement just one of the arguments to make it work. And this is one I get from the Fluent Python book. Like, this was the piece he used back then just to check the request, right? The files. And you still have those headers there. So it's huge just to type. So if you want this dynamic, to be dynamic, as Python like are used to, you have to do a lot of typing, right? And it gets worse. So I have a couple of friends that code TypeScript, right? And we have some chats to conversate. And a friend of mine was very angry. He showed me this. Hey, I'm gonna type error here. I cannot read it. Like, what the hell is this, right? I do not understand anything that's going on here. So there's also this thing, like, you want to represent everything. You want to handle the word, right? But then, like, when an error comes up and it's not usable, right? You don't have much work to do with that. And there's also that touch me, like being from real life. There's some lies here. This is a piece of code that I changed from where I work. And you can see, like, I have roles like get entities. Okay, this is a generator. I have a tuple and a dictionary. Okay, nice. It's kind of odd, like existence, row of dict, the type is already saying, what does check? I don't need to do that. So just yield entity and let's go. And let's go, errors. Then our alert system said, hey, like you get 89 times 0 to less for hours. And because we try to get like none, we try to use get on none. So this typing is a lie. So you have static typing, and this is also something from that paper. That a lot of projects have types, they use types, but they don't run my type. They're not running any type checks. So they use that from the IDE for the developer experience, but not like as a check to see if the code's working. They just add it like to help them while they're typing. And yeah, that caused some bugs. There's a book that I like very much that I also work with Ruby. This book from Sandy Metz, and there's something that he tells that is very nice, I like it a lot. Is that like static and dynamic typing both make promises, and each one has costs and benefits. Static typing aficionados cite the following qualities, right? The compiler unearths type errors at compile type. Visible type information serves as documentation, and compile code is optimized to run quickly. There's a lot of things to say that. And okay, but if you want these qualities, right, you have to make some assumptions. You have to, in order to get those things, right? So you have to assume that, have the assumption that the runtime errors will occur. They will happen if you don't have a compiler, right? And the programmers will not understand the code unless you have those type, right? And the application will run slowly if you don't have that. So is that the case? And who likes dynamic typing will tell, hey, the code is interpreted, dynamic loaded, like there's no compile make. Just run it and you get feedback, you just have those steps, right? And the source code does not include type information, and metaprogramming is not include type information. Like it's easier to see things. Like it's clear. Like they try to make the context. And if you want to do metaprogramming, if you do crazy things that help, that creates a nice API that helps your users, it's much easier to do that way, right? Your typing is not going in that direction. And if you believe those things, like these qualities, right, then you overall the development is faster without the compile type. That makes sense. The programmers find it easier to understand code when it doesn't contain type declarations. When I was typing C, the types getting my mind, was not helping me, right? And you want metaprogramming, you want that power, right? And conclusion. Is there a conclusion? So the idea is like typing, there's a lot of typing, a lot of language that uses typing. And how does it work? Like that helps on other things that help with all this checking. There's some people say about other languages strictly type it and you get all this behavior that tells you, hey, your code are correct, your code works. But there were some emphasis here about like, hey, sometimes typing is just testing. Why don't you run tests? Why don't you add tests, right? If the things you're trying to get are bugs because you didn't forget a type, you didn't check for no, why didn't you have a test then? You didn't test anyway sometimes, so why you're not doing that? And one of my points here is that when I point the good things, I didn't put, hey, bugs did not happen. Bugs happen with typing. And the good things that we get there is not, in my opinion, what I'm trying to say, convince you is that we get the developer experience, right? I get the experience on my IDE, right? I don't need to go to the documentation. I have a lot of things there for me to tinker, for me to play with, right? It's not that I want a fast compiler. It's not that I want not to make bugs. And these things will happen. It's not because of types. So the typing idea, is, in my point of view, is not much of the confidence of my code. It's something for me to develop it faster, to have more confidence, and be happier coding, right? I'm happy with C, and I'm very happy with Python. And I get even more happier with all these features, right? All these things that we can get from that. And yeah. Yes. What else? Oh, there's some references that I didn't say. And questions?
Hi, great talk. I had a question about the study that you mentioned about the repositories using type hints and all of that. Do you know if they also analyzed docstrings? Because there's many ways in which you can type a function just through a docstring instead of annotations.
Yeah. As far as I look here, no, they only look at the typing, strictly typing, or typing in the files, or like the PYI file. So they didn't look at that. So there's there's something that you can look, because as I said, like PyCharm, if you have docstrings, you have typing, you have that safety, you have all those features, right? And so yeah, that's improvement for the code. But yeah, they didn't look at it.
Another question I had, like, what do you think about many of these tools? You can override the type of a function return, right? So let's say some function returns a typed dict, but I can type the variable as just a dict, and I'll lose all the type information. Do you think these tools should kind of, let's say, inherit the type? So okay, if I'm typing a variable as just a dict, but it can infer from the function that it's a typed dict, then it won't lose that information. Or we just shouldn't type the variable at all because the function is already telling us what type the variable has.
Yeah, so that's a great question, because like this is something that sometimes in my work I have, because sometimes like I'm using VS Code, so I'm using PyWrite, right? And if I rover some variables, PyWrite will tell me, hey, this variable like was not defined. Like if it sees the variable is all caps, right? It says, oh, this is Python, this is a constant, right? That means here's a definition. The definition, hey, this is a string. And not show when I hover, it doesn't say, hey, it's a string. He gives me the value of that. And the type he gives me is like literal in the value of the string. So I rover it and I know the type, like what's reading there, right? Much more than type, I know exactly what's there. And I have some friends that are, but if you just type the constant with stir, then you lose that information. If I'm on PyWrite, we'll hover it and say, hey, this is a stir. But what's inside there? I don't know. But if you're using PyCharm, it doesn't care. You hover it and show the definition, gives you the line and everything else, so you don't lose that. So that, for now, I would guess is dependent on the type checker you're using, right? For example, my type, if you put something that is, you have a variable and you put that, you have a list of integers, then you put a stir there, a string there. My Py is going to say, hey, this is any. This is a list of any. While if you run the Google one, like PyCheck, I believe, it's going to tell, hey, this is a list of a union between stir, a string, and an integer. So that's dependent on the type checker.
Any more questions? No? Thank you, Caio.
Thanks.
And now, welcome Nitish Har, who will present us how we can enhance user experience with large language models.
Okay. Hi everyone. Oops. Okay. Okay. Hi everyone. I'm Nitish, and today I'm here to present on like how you can integrate uh, LLMs into your applications for a better user experience. And so, a bit about me. Uh, so my background is mostly data engineering, and I'm currently working as a developer advocate at Couchbase. For those of you who are not familiar with Couchbase, it's a document database with which is quite similar to MongoDB in terms of what you can achieve with it, but like we have a different architecture, so it's much more performant at higher scales. And in the developer relations team, what we do is we build a lot of integrations with other tools that developers are familiar with. So building things like IDE plugins or building things for vector search and AI and so on. I'm based in Munich, and I also run a meetup called PyData Munich. So coming to today's agenda, so there's like a lot of different things happening. So I'll walk you through like the motivation for using large language models in your applications, and then I'll go through like 3 different techniques, basically prompt engineering, RAGs, and agentic workflows. Yeah. And so over the last 1 or 1.5 years, generative AI has been taking off quite a lot. So there are like large language models and like all kinds of different models to do all kinds of different things like generating images, generating videos, generating code, and so on. So, I mean, there are, just a brief overview of what large language models are. So these are models that are trained on huge corpus of data. And by huge corpus, practically the entire internet, all the books, and practically all the public websites, even including some private websites that the models were not authorized to. So they're extremely good at working with text. And like some of the common examples are like GPT-4, Llama 3, Cloud, Gemini, etc. So LLMs are powerful for certain use cases. And if you can combine these use cases, or if you have a use case similar to these in your application, you can combine them. You can use LLMs to provide a lot of difference to the end user. So some of the common examples are like chatbots. You can summarize content pretty well. You can do classification of content. For example, you have reviews on a social media or like product reviews, for example. You can get the sentiment of the product based on this analysis. This is like a study that I took from the internet. So Klarna, they basically use LLMs or like AI for their customer service use case. And according to their report, it could handle things quite well, and it was quite, people couldn't really, the end user experience was not too different from what they would get from a human customer service agent. And yeah, these are more examples. Like you have coding assistants like Copilot or Zencoder. And this one, I'm not sure if many of you have seen this. So this is like pretty recent. This is like a project called Notebook LLM, which is from Google. And basically it allows you to provide like a lot of resources. You can specify like web pages, URLs, YouTube links, all kinds of things. And you can ask questions about it. You can also generate a podcast even on it. And this is quite cool. Yeah. And as with all things, they also have their issues. So these are just a couple of things that I found on the internet. So one was like Amazon. They had deployed a model that allowed you to search for things on the reviews. But as it turns out, you can do much more than that. So for example, you could use it to generate code or, yeah. You can, basically the LLM was not tuned to just respond to reviews. And there's another case where someone was, so this was like from a car retailer. So they had a chatbot which allowed people to get help in picking what they like. And apparently this guy just hacked or hijacked the prompt and asked it to agree to the customer, and basically he got a car for $1. Okay, so with that, I'll tell you go through 3 techniques and how you could use them in your applications. So the very first one is prompt engineering. It's probably the most straightforward one. You are essentially guiding the LLM to perform a task for you by providing specific instructions. Yeah, and this topic is quite vast. Like, for example, this was a paper that was published, I think, earlier this year, which covered all the different prompting techniques, and there are more than 40 different categories, and these are just for text. So in this talk, I'll just cover a couple of things that might be interesting for you. One is output structuring, which means that you can ask the LLM to respond in a certain output, for example, like JSON or YAML, for example. And the other thing which I would show is the concept of zero-shot and few-shot prompting. So the idea here is you provide some examples of the outputs that you would like from the large language model, and the model would adapt to providing them. With zero-shot, you just don't have any examples, while for few-shot prompting, you provide a few examples, and based on that, the LLM adapts to your answer. Okay. Oops. So let me just quickly show you a notebook. Yeah. So this is just using ChatGPT or GPT-4o, and I have a conversation here. I'm using, so for those of you who are not familiar with this is LangChain, a framework which allows you to switch between these LLMs quite easily. So here I ask a question. Yeah, so you have a system prompt, which is you're a helpful assistant that answers users' questions. What is photosynthesis? And you get a scientific answer. And if you want to, you can do other things, you can instruct the model to answer a 5-year-old. So this is inspired by this. I explain I'm 5, Reddit, forum. And yeah, you get a smaller, much more accessible to a child answer. So photosynthesis is a magic trick. Yeah. And I'll also show you the zero-shot prompting and few-shot prompting. So for example, you have here, this is the prompt is provide a summary of historical events as if explaining to a 5-year-old. And yeah, so you get some text. So yeah, it kind of covers that the war lasted for 4 years and so on. But you can actually provide some examples. So for your example here, there is the American Revolution was when people in America fought to be free from British rule. And then World War II was when many countries around the world had a big fight, and in the end they worked together to make sure that no one could start another huge fight like that again. And based on this, now if you generate the output, it would be slightly different. So this is kind of what you can do with few-shot prompting. So you can provide examples that allows the model to adapt to it. Okay. So, prompt engineering, it works quite well in practice. There are some obvious limitations it has knowledge limitations, either by the training cutoff for the large language model or, basically that. Or the training source was never part of it. And due to this, it tends to hallucinate. So it can come up with answers which look reasonable, but they are not. And the other thing is the hijacks that we saw earlier. So essentially, the person could overwrite the prompt. And this is hard to protect. You can do some inputs. You can you can put a prompt to the LLM to not allow anyone to change it, but I mean, still there are workarounds and it's really hard to protect against it. I mean, some recommendations is to provide context because like LLMs, they love context because they have been trained on huge volumes of text without much context, or like in some cases context, but always context helps. And it's also good to have like concise prompts with things of what it should and should not do. Okay, so the next thing, next technique is RAG, or retrieval augmented generation. So the idea here is that you might want to train, or you might want your model to answer things that it has not been trained on. This could be internal private documents that are not accessible to the LLM, or it could be things that were after the cutoff date for the model training. And so essentially, the core of it is you have these two parts, retrieval and generation. The idea is that you retrieve some parts of some documents or some context that is not part of the LLM corpus from a vector store, and then you inject this into your prompt so that the LLM can answer based on the prompt. So I mean, in most cases, you would typically ingest your data that you want the model to answer, and then you would basically search for it at the time of query from the user, and then ingest it into the context of the LLM, and the LLM can answer it. Yeah, I mean, so this is the workflow. So you have your custom data, you generate embeddings for it and store it in a vector store. And then at the time of generation, you basically ask the question to the vector store, and you get like some documents that are relevant to this question, and then you inject this into the LLM context. Yeah. So I'll show you like a short, quick demo. Hopefully it works. Yeah, so this is like a really simple use case where you can upload a PDF and then ask questions about it. So for this use case, I'll just use the documentation from the LangChain website. So I just exported a PDF of it. So I'll just upload it. Yep. And yeah. So what is happening right now is this document is getting ingested into Couchbase. So there's like a bit of splitting of this document because it's a huge document, and you typically want the document to be split into smaller sections so that you have crisp and concise context that is provided to the LLM to answer. I think it might not be working. Let me check the internet. Let's see. Yeah, let me just quickly go to my app. Yeah. I'll just restart it. Yep. So, yep, I'll just upload this document. And yeah, now it's working. Yep. So now I can ask questions like, how can I use Couchbase as a vector store in LangChain? Now, you should typically get like two answers. One that is generated by using the RAG, and one just by the pure LLM. Yeah, it takes a few seconds. Yeah. And in the meantime, we can take a look at the database. So PDF chat. So you can see like the document. So this is how a document looks. So you have some text, and you have the vector embeddings for it. And there should be some metadata as well associated with it. Yeah. And I have like a vector index defined on this that tells you that embedding vectors are like 1500 dimensions, and I want to do the dot product similarity to fetch the relevant documents. And yeah, so now you got like the answer, yeah, to install LangChain Couchbase, and yeah, basically how it should be. And then you also have this answer from the LLM directly, where it doesn't know that you can use LangChain, Couchbase with LangChain. So it is asking you to create your own vector store implementation and so on. Yeah. Oops. Yeah, so that's that. And so these are the typical components of a RAG pipeline. So you have like the ingestion of documents, and you do want to chunk the documents into smaller sections, preferably with like some overlap so that you don't miss any context. So you do this because for an LLM, it makes sense to have like crisp, concise documents that it can process. And then there's like this embedding models that are important because depending on your embedding models, your vector search could be different. Like some models could be better for some use cases. And in the retrieval of documents, you have vector search, which you perform to generate the documents that are closest to your search term. And then you have something called re-ranker. So this is typically used when you have a lot of documents that you want to put as part of your context. So typically you would do like the most relevant documents should be at the start of the context or towards the end, because that's due to the way that LLMs are trained. So they perform better when these most relevant answers are towards the top or the bottom. And for the generation, you just use the ranked documents as context. Yeah, I mean, this is like a small demo. Let's see if I can quickly show you that. Let's see. So this is like just something a bit more complex. So here I just ingested all the Couchbase documentation, and I can ask questions like, what is vector search? Yeah, hopefully, yeah, so it works. So you get like an answer and like some sources on where you can find more information. And you can also ask follow-up questions like, how can I do it in Python? Now, it should detect that it is, I'm asking about vector search in Python, and then, yeah, it comes up with like the code that allows you to do that, along with like link to the documentation. Yeah, I mean, just like a small kind of real-world use case. It's the same. So you have like documents that were already ingested. So you have embeddings and then text, which is part of the website, and like information about which page it is and all those things. Yep. So the code is also available, so you can use it if you like. So, I mean, RAGs are more powerful than prompt engineering. I mean, but at the end of the day, it's again just like an efficient retriever. So it can only retrieve information that it already knows. So it is better than prompt engineering in the sense that you can ingest custom data that is not there. But I mean, at the end of the day, you can't do things like, for example, the code that was generated before, you can't run it. So those kind of things are not part of a RAG. I mean, one thing that might be interesting is like, this is an area of really active research. So how can you measure the performance of RAGs? And this is quite tricky because it's not deterministic. The answers are not deterministic. And there are like two different approaches. One is like human evaluation, where you do some kind of, let's say, thumbs up, thumbs down kind of feedback. And like you get like some text field where you can say that, okay, this thing doesn't work, this answer is totally off, and those kind of things. And based on that, you can do something. The other approach that is common is you use a large language model to evaluate the response of a large language model. And there are frameworks like RAGAS that can do that. Typically, you would have like a set of questions and like benchmark answers. And the way it works is you use the LLM to see if the answers, so let's say you can try to identify the important parts of the answer from the benchmark answer, and you try to see if those are part of your context and LLM provided answer. Yeah, and yeah, I mean, it's a bit complicated, but still that's one of the good ways you can use to measure the performance of RAG systems. Okay, so I mean, the last technique that I want to share with you is like agents. So the idea here is that it's a bit more dynamic. So you give the LLM the opportunity or like the freedom or control to observe what is the problem and try to come up with some solutions and then explore them one by one and like based on the results act accordingly. For example, if the output is not what is required, it can try to come up with like a different answer. And mostly you do it by like you provide some tools or like capabilities to the LLMs. And most modern LLMs, they have this capability. And one of the common approaches like React, which is like reason plus act. So you come up with like a chain of thought kind of model where you say, okay, I can tackle this way, and then it basically calls all these tools to solve that. And if some of them fail, it tries to come up with the better ones. Yeah. So here I have like a different example. So this is something called something which so like at Couchbase we have something like SQL++, which is like SQL for JSON. So it's mostly SQL, but like with some extra things because you need to work with JSON, like all the nesting and stuff. And like if someone, I mean, so this could be this is just something that I developed because like let's say you have a non-technical person and they want to get some data from the database. I mean, it's not that trivial to come up with queries if you are not familiar with it. And this is just like an idea of how you can come up with a query and then get the data from the database. So, I mean, here the idea is like, so the graph on the right that you see is like a flow diagram for this. So you start with like getting all the list of collections. So collections is similar to tables in relational area. And then you want to identify the structure of the documents. I mean, it's not purely a schema because in document databases, you don't have this concept of schema. They can be diverse across all the different documents. And then based on the schema, we tried to come up with a query. And then once the query is generated, you run it. And if it is not right, yeah, maybe you get an error. You go back again and try to generate the query again. I mean, that's the idea. And once you get a query that's sufficiently good, you get some output, and that's it. So, I mean, let me try to run it now. Yeah, so hopefully this works. So, I mean, I can ask things like, let's say, suggest me some hotels near Westminster Abbey. Yeah, let's see if it works. I mean, most of the data here is like from the US and UK and France. So that's why, yeah. And yeah, I mean, it will take a bit of time. And in the meantime, we can actually look at, yeah, not this one, yeah. So this is like the whole application from the, yeah, I mean, it's using LangGraph, which is like a framework to build agentic applications. And you have like a state which is getting passed across all these different functions. And each function tries to answer based on what it can. And like you have like list of collections. So this is quite deterministic because you just need to parse through all the collections in this database. And for the schema, yeah, I mean, it's using a LLM. So what we are doing is like sending some documents or like some sample of documents with types along with it, and then sending it to an LLM and asking the LLM to generate the schema. And then once you have the schema, it's trying to generate a syntactically correct query And yeah, I mean, there's like things like you don't want the user to write to the database. You only want read, access, and stuff. And you can also see things like the output structuring. So you only want like SQL++ query and nothing else, because typically you have like all these extra things. And yeah, I mean, you just invoke it and then you do some cleaning and then running the query and you should get the output. And here, like you have the conditional checks, which is like, yeah, if it's an error, you should go back to generate query again, and so on. Yeah, I mean, now let's see if this worked. It didn't work. Okay, let's try something else. Or maybe, let's see what the issue is. Yeah, I think, yeah, it failed to generate a query, but we can search something else. Find things to do near Buckingham Palace. Let's see. Yeah. This should work, but let's see. If not, we can go to more simpler examples. Yeah. Because ideally we should get like, so in this case, I'm just using travel sample data. So yeah. So you have things like landmarks and hotels and airports and stuff. Yeah, it's still running. Yeah. Yeah. If this doesn't work, let's see. Yeah, but like, I mean, in this screenshot, you can see some of those queries that were generated. So, I mean, things like unnest, those are things that are specific to SQL++, because you want to unroll a JSON. Yeah, so it worked. So you can see, oh, this is nice. I didn't expect this, but yeah. So you had things like select name, activity, address from landmark where city equal to London. And because this data set also has like latitude and longitude, it's also trying to identify the latitude and longitude of Buckingham Palace. And yeah, I mean, you got like, yeah, so this looks right. Buckingham Palace is one of the recommendations. Yeah. Yeah, I mean, then there's like a pub. Yeah. So I'm happy with the answer. But I mean, you can do this for like whatever you like. Yeah. Based on the data. Okay. So I mean, so the thing with agents is like, I mean, in theory, it sounds really good. Like you can do a lot. But in practice, like some of these complex workflows, it's not so easy to really model them. And like some even require like human intervention. For example, in the case of like a customer support agent use case, you might not want your agent to like offer something like a free accommodation because of some issue. So this might need like the user to, like a human person to approve, for example. And you can also combine agents with RAGs so that like you have more knowledge than what the LLM has. Yeah, for example, in this use case, you can have things like all the different SQL commands or SQL++ keywords and stuff. I mean, one thing to note is that like you always have to check these prompts with these LLMs because even though you test them independently in an agentic workflow, it might look a bit different than what you might expect. Yeah, and so I'm nearly out of my time, so I'll just quickly conclude. So the key takeaway from it is there's a lot of things that you can improve for the end users using these LLM tools. I mean, even if you don't use them, you need to at least keep track of what you can do with these LLMs. And you need to really be careful with privacy considerations, especially in Europe. And this is like a really rapidly advancing field, and new models are getting released every week. and it's really hard to keep up. So yeah, I mean, this is maybe like some things that you might not have been able to achieve last week might be possible next week. And yeah, I mean, that's always the thing, because these models are getting more and more powerful, and it's really hard to keep up. And yeah, I mean, if you want all these demos, they are like available on GitHub. Yeah, I mean, the last one, I need to still add like a few README and stuff, but the code is still there. And yeah, I mean, there are even examples in Node.js. Yeah. And that's it. Like, I mean, thanks. And if you need to, yeah, reach out, you can reach out. And if you want to use Couchbase, you can use Capella, which is our managed version of database, Couchbase, and it's for free. We recently launched this free tier. So yeah, I mean, go crazy with it. I mean, you can do whatever you want. Yep. And also we have a like a community edition, which is also quite powerful. Yep. And yeah, questions. Thank you.
Hello.
Hi.
Very interesting presentation. These tools are getting more and more use. For instance, in healthcare, I work with clinical professionals that sometimes want to ask some questions related to the data that we have for some patients. A challenge, like you said, is to ensure that the privacy and that no data for other patients or from the database that we don't want the user to know. We just want the LLM to give the answer to the query of the user and nothing more than that. How do you think we can limit the action of the LLM so that it doesn't expose unwanted data to the person that is querying it? How do you think we can approach this to ensure that?
Yeah, that's a really good question. I mean, so there are like even other frameworks, like for example, DSPy. I don't know if you have heard of it. So these are things that are like a bit more advanced than what all these plain LLM frameworks like LangChain and Llama Index and all those things do. So what it allows you to do is like you can do more conditions and you can do more validations and stuff. And so that's one option. And the other thing is like always use like a local model, which is like not even connected to the internet. So you get like a bit more privacy. Yeah.
Okay. Thank you. Very interesting.
Thank you.
Thanks.
Okay, now we'll have the lunch break. We'll be back here at 2 o'clock.
you.